Hello friends, welcome to my channel. So in this video we will discuss about that today's problem of the day's problem means and name is move last element to the front of a linked list. So let us discuss about that problem statement. You are given a head of the linked list and you have to move the last element to the front of the linked list and return the list. Means of that you have to be remove the last element from the linked list and it will it will put on that front of the linked list. Okay, and after that we will return that linked list entire linked list. Okay, so let us discuss about that problem example. Here are the size of a linked list, that is n is equal to 5, and here is the element, that is 2 5 6 2 1. Okay, 2 5 6 2 1. After this removing of the last element, and and we will put that up front of the linked list, that our resultant output is this 12562. Okay, so we will draw that a linked list at here, that is that is a 2. Okay, 2 5 6 2 and 1. This is our given linked list, and this is our head, which is point to our front value of a linked list. Okay, so what will our approach? Okay, firstly we will initialize two variable, that is t1, which is point to that is head next. Okay, and t2, that is point to our head value. Okay, understood? That is means of that when we will create that is this pointer, that is t2 will point to that head value, that is 2, and t1 will point to the head next value, means of that t1, means of that a value is 5. Okay, so next step will be, that is we will run a while loop till we will run a while loop till, that is while when our t1 next is not equal to null. Okay, and t2's next will not equal to null, and t2's next to next, okay, next to next not equal to null, then we will simply move to this next element. That is how it is working there. We will simply check that t2's next to next means of that a 6, it is a null, no. So we will simply update our t2 to t1. We will simply update our t2, that is here. Okay, and t1 next will check that is not, this is not equal to null, this is not equal to null. So what we will do, we will simply update our t1, and t1 will be point at here. Okay, then what we will do, we will simply again check it, that is t2's next to next, t2's next to next means of that next to next means of that 2, that is not equal to null. So what we will do, we will simply update our t2, and our t2 will be point 6, point here, and and t1 next means of that is 2, t1's next means of that is 2. So this is not equal to null. So what we will do, we will simply update our t1 and t1 will be here. I hope you all understood very well. And again we will check that t2's next to next is not equal to null, that is 1. So what we will do, we will simply update our t2 and t2 will be here. Okay, and t1's next value is not equal to null. So what we will do, we will simply update our t1 and t1 will be here. I hope you all understood very well. Then again we will check that t2's next to next, that is null, because this is not any value present at here, that is null. So t2's next to next is null and t1's next to next is also, and t1's next is also null. So what we will do, we will nothing will do, we will simply update our t1, simply update our t1's next value will be, t1's next update is head value. Okay, that is, then our point, then our value will be that is, and our value will be that is 2. Okay, and we will update our head, we will also update our head, that is head will be point t1 variable. Because of that, in pointer t1, that is store the last value address, that is last value address. Value address means of that this node value, this node value address present in this variable. Okay, so we will update the head by the t1. So our our head value will be point at here. Okay, I hope you all understood, and head will be updated, and at the end our last procedure is that, we will update our t2's next value, t2's next value, that is which is pointing, which is pointing, that is t2's next value pointing to the 1, to the 1. So what we will do, we will simply update, is null, null. That is means, that is how it is working. Means of that, we will lose the connection at here, and it is null. Okay, so our finally output will be draw at this 1 2 5 6 2, 1 2 1 2 5 6 and 2. Okay, so I hope you all understood very well. And before this is entire working process, we will simply check it, if only one value is exists, that is 1, and it is pointing by the head value. So what we will do, we can't delete this value, we can't delete this because it is our head value and only one value is present. So what we will do, we will simply, we will check that if head next value, is equal to null, means of that this null value, head next is null. So what we will do, we will simply return our head, or head value is null, so we will simply return our head. I hope you all understood very well. Okay, so let us discuss about that is our code. This is our C++ code. Firstly we will check that is head is not equal to null and head next is not equal to null. Okay, that is means of that if head is equal to null and head next is equal to null, so we will simply return our head. This is our base case. And here are the all the logic that was applied here. a, a temp variable will initialize, that is head next, and temp1 variable which is initialized by the head value. Okay, and we will run a while loop till that is pointing the last and second last node, and after that updating process at here, and we will simply return our head. So this is working fine, you can check it. I hope you all understood very well. This is a C++ code, and here are the Java solution. Simple, nothing changed. Okay, so this is also working fine, you can check it. Okay, I hope you all understood that very well. If you have any doubts, so please comment. Please like my video. Please subscribe my channel.